In this session, we are going to solve a few problems based on arithmetic progressions. We know that A represents the first term, D represents the common difference, and the general term is given by Tn equals A plus n minus 1 times D. And we also know that n has to be a natural number, and the common difference is given by n plus 1th term minus the nth term, right? So these are the concepts that we know so far in arithmetic progressions. So let us now solve a few questions based on these ideas. The first question is as follows. Show that the nth odd natural number is given by 2n minus 1. That is, we have to show that the nth term, so let us write the odd natural numbers. We know that the smallest odd natural number is 1. The next odd natural number is 3. And the next one is 5, and so on. We have to show that the nth odd natural number. So I have to show that the Tn, that is the general term of this particular arithmetic progression, is given by 2n minus 1. So I know that the AP is 1, 3, 5, dot dot dot. I have to show that the nth odd natural number, that is the nth number in this sequence, I have to show that the nth number is given by 2n minus 1, right? Now, how can I find the nth term? What I can do is, I know that the AP is 1, 3, 5, so I can find the general term of this particular sequence, and that is going to be the nth term, right? So in this AP, I know that the first term is 1. The common difference is 3 minus 1, T2 minus T1, which is equal to 3 minus 1, and that equals 2. So the common difference of this AP is 2. Now I have to find the general term. So to find the general term, I can say that the general term Tn is given by A plus n minus 1 times D. And therefore the nth term is A is 1 here, plus n minus 1 times D is 2, right? And therefore the nth term is going to be 1 plus 2n minus 2 when I open the brackets, and that equals 2n minus 1. Therefore the nth term of this particular AP is 2n minus 1, and hence I can say that the nth odd natural number is therefore given by 2n minus 1. Now just to show you how this works very well, suppose I take n equals 1, that is I am trying to find the first odd natural number, then T1 is going to be 2 times 1 minus 1, which equals 1. And that matches our understanding that the first odd natural number is 1. If I take n as 2, then T2 is going to be 2 times 2 minus 1, that's going to be 4 minus 1 is 3, and that again matches our understanding that the second odd natural number is 3, right? And hence this answer is right, because it is helping us find any odd natural number, and hence the nth odd natural number is 2n minus 1. So again I will pause for a couple of seconds before moving on to the next question. Moving on to the next question. We have to show that the nth even natural number is given by the expression 2n. So which are the even natural numbers? The smallest even natural number. So of course natural numbers start from 1. But I want the natural number to be even. So the smallest natural number which is even is given by 2. The next even natural number is 4. The next even natural number is 6, and this goes on. Therefore, this forms an AP for sure, where in this particular AP, I can say that the first term is equal to 2, and the common difference is the second term minus the first term, which is 4 minus 2, which again equals 2. So the first term is 2 and the common difference is also equal to 2. And now we want to find the nth even natural number. So we basically have to find the nth term. We have to find the nth term in this particular sequence, right? And now I can find the nth term. It is basically my general term. So nth term is given by a plus n minus 1 times d. Now a is 2 plus n minus 1 times 2. D is also 2. So this becomes 2 plus 2n minus 2. Now 2n minus 2 cancels, and therefore the answer is 2n. And hence I can say that the nth even natural number, is therefore given by the expression 2n, or rather this is the general term to find any nth even natural number. Let us see if this works again. When n is equal to 1, t1, so t1 is 2 times 1, that equals 2. When n equals 2, t2 is 2 times 2, that equals 4. When n is 3, t3, that is the third term, is 2 times 3, that equals 6, and so on. So the terms are 2, 4, 6, and so on. This is how I can solve this particular question. So in the previous problem we saw that 2n minus 1 represented the odd nth natural number, whereas 2n represents the nth even natural number. Pausing for a few seconds. Moving on to the next question. Let's take a look at this question. How many terms are there in this particular AP? So for this AP, this is my first term, this is my second term, this is the third term, and this is the last term, right? This is the last term, and I want to find what is the position of this particular term. So I can say that in this AP, I know that the first term is 187. First of all, is this an AP? Let's quickly check. T2 minus T1, second term minus the first term is 194 minus 187, that happens to be 7. And T3 minus T2 is 201 minus 194, that is also equal to 7. So 7 is therefore the common difference. So I can say that D is 7. And 439 is the nth term. So let's assume that this is Tn and this is T1. So basically I'm trying to find the value of n over here. So Tn is 439. Now I know that according to the general term for an AP, I can say that Tn is equal to a plus n minus 1 times d. So Tn is 439. So 439 equals a is 187 plus n minus 1 times 7. So 439 is equal to 187 plus 7n minus 7. which means 439 is 187 minus 7 is 180 plus 7n, and that means 7n is 439 minus 180. So now if I subtract this, I get 259 is equal to 7n, which means n is equal to 259 divided by 7. And therefore this becomes 37. So the value of n is 37. This implies there are 37 terms, in this particular AP, right, in this AP. So this is the final answer. Again over here I use the concept of general term, and please note that 439 was equal to Tn and not equal to n. Had they asked me find the 439th term, then in that case n would be 439. But here they have asked me which term is 439. That means 439 forms Tn, and I had to find the value of n. Basically, I had to find the position of 439 in this particular AP. So this is how I would solve this question, pausing for a few seconds. Moving on to the next question. If the sum of the 32nd term of an AP, so we are taking the sum of the 32nd term of the AP and the 48th term of the AP. So it's given that the sum of 32nd term and the 48th term is equal to 190. It's given that the sum is 190. So this is given to me. I have to find the 39th term. I have to basically find the 40th term. So there was a correction. I made that correction. So I basically have to find the 40th term in this particular AP. Now I can say that the 32nd term is going to be A plus 31D, and the 48th term is going to be A plus 47D. This is going to be equal to 190. Combining the like terms, A plus A becomes 2A, and 31 plus 47 becomes 78D, is therefore equal to 190, and that implies I can divide this whole thing by 2. So 2 times A plus 39D is equal to 190. I took 2 out as common, and therefore A plus 39D is therefore equal to 190 divided by 2, and A plus 39D is therefore equal to 95. Now what is the meaning of A plus 39D? A plus 39D is the 40th term of this particular AP, and therefore I can say that the 40th term of this AP, the 40th term of the AP is therefore going to be equal to 95. Now somebody can question saying that why not find the 40th term as A plus 39D? You can calculate A and D, but the problem is there are no two equations given over here to calculate A and D. A and D are two different variables. So to find two variables, I definitely need to have two equations, which is why over here I was not able to find A and D separately, but I was definitely able to find A plus 39D, and that was my 40th term. So this is how I solved this particular question. Take a note of it, and then we will continue. Moving on to the next question. We have to find the 101th odd natural number. Also, which odd natural number is 501? So we know that odd natural numbers, so let's find the sequence. The sequence of odd natural numbers is 1, 3, 5, 7, dot. And we have to find the 101th. So let us first find the 101th odd natural number. It means we have to find first, we have to find the 101th odd natural number, that is T101. And then we also have to find which odd natural number is 501. That is, we want to find n. We want to find the order of 501 in this particular sequence. That means we have to find n so that Tn is 501, right? So let us now first find the general term. So I can say that for an AP, general term Tn is given by a plus n minus 1 times d, and that is going to be a is 1 plus n minus 1 times 2, d is 2. That is 1 plus 2n minus 2, which is equal to 2n minus 1. So the nth term is therefore given by 2n minus 1. And now I have to find the 101th term. So T101 is going to be 2 times 101 minus 1. And that's going to be 202 minus 1, which is equal to 201. Therefore, the 101th odd natural number, is 201. This is the answer to the first part. Now the second part says which odd natural number is 501. So Tn is basically 501. The formula for Tn here that we have derived already is 2n minus 1, which equals 501. Therefore 2n equals 501 plus 1, and therefore 2n is equal to 502, which means n is equal to 502 divided by 2, that is 251. Therefore 501 is the 251st term of the given AP. Right? So this is how we can solve this particular question. Again, pausing for a couple of seconds before moving on to the next one. Let's take a look at the following question. Jana saved rupees 5 in the first week and then increased the weekly savings by rupees 1.75. That means in the first week, the savings were rupees 5. In the second week, the savings were increased by rupees 1.75. That means the saving was 5 plus 1.75, that is rupees 6.75. In the third week, the saving of the second week was increased by 1.75, that is it becomes rupees 8.50. So in the first week, this person has saved rupees 5. In the second week, the saving is rupees 6.75. And in the third week alone, the saving has been rupees 8.50. So if you look at the savings, let us look at the weekly savings. The weekly savings are therefore rupees 5, then rupees 6.75, then rupees 8.50, and so on. We notice that the weekly savings are in an arithmetic progression. So in this AP, I can say that the first term is 5 and the common difference is 6.75 minus 5, which is equal to 1.75, right? This is the common difference. Now we have to find in which week will the savings reach rupees 29.50. So I can say that the nth term is therefore 29.50. And I know the formula, so I have to now find in what week, right? So basically I'm trying to find the value of n. In which week? So is it the 20th week or is it the 17th week or the 27th week? That is what I'm trying to find over here. So basically Tn is 29.50. I am trying to find the value of n. I know that Tn, and I can apply this formula of AP because the weekly savings that we have listed, these basically form an AP, if you notice. Yeah. So therefore Tn is equal to A plus n minus 1 times D. Tn is 29.50 is equal to A is the first term. A is 5 plus n minus 1 times D is 1.75. And therefore 29.50 becomes 5 plus 1.75 times n minus 1. So this means 29.50 minus 5 is equal to 1.75 times n minus 1. So 29.5 minus 5 is 24.50 is equal to 1.75 times n minus 1, and therefore 24.5 divided by 1.75 is equal to n minus 1. Therefore, multiplying the numerator and denominator by 100, I get n minus 1 equals 2450 divided by 175. Now 2450 divided by 175 is equal to 14. So n minus 1 is 14, which means n is equal to 15. Therefore, the weekly savings in would be rupees 29.50 in the 15th week. Right? This is how we can find the value of n here. So again, we tried to convert a word problem into an arithmetic progression problem by correctly understanding the conditions that were given, and then we mapped the quantities that were known into the quantities related to AP. Like we found A, then we found D, and we tried to understand what was 29.50 that happened to be Tn, and once we mapped everything to the conventions of arithmetic progressions, we were now able to find the required answer, right? So always try to convert a given statement or a given word problem into the parameters related to arithmetic progressions, and then we can easily solve the question. Pausing for a minute. Moving on to the next question. if 5 times the fifth term of an AP, if 5 times the fifth term of an AP equals 8 times the 8th term, then show that the 13th term of the AP is equal to 0. Okay, so let's note down what is given. It's given that 5 times the fifth term, 5 times the fifth term of an AP is equal to 8 times the 8th term, that is 8 times T8. We have to show that the 13th term, that is T13, is equal to 0. So I'm going to pause for a few seconds and maybe you can figure out what can be done about this question. So now let us frame the equation based on what is given. It's given that 5 times the fifth term. So 5 times, how can I express the fifth term? I can write the fifth term as a plus 4d is equal to 8 times the 8th term, that is 8 times a plus 70, right? And now I can definitely open the bracket. So 5 into a becomes 5a plus 5 into 4d becomes 20d is equal to 8 into a is 8a and 8 into 70 is 56d, right? And therefore, let us now arrange all terms on one side. So 0 is equal to 8a plus 56d minus 5a minus 20d. Therefore, 0 is equal to 8a minus 5a is 3a plus 56d minus 20d is 36d. And now dividing throughout by 3, I get 3 times a plus 12d is equal to 0. And therefore, a plus 12d is equal to 0. Now, what is a plus 12d? A plus 12d is the 13th term. That is, T13 is equal to 0, right? And that is how we prove that the 13th term of this AP is going to be 0. So what I basically did was I framed the expressions for T5. T5 was a plus 4d. And I framed the expression for T8. T8 was a plus 7d. And then I just opened up the brackets. I rearranged all terms on one side. So I got a plus 12d is equal to 0. Now a plus 12d basically was the 13th term, right? So a plus 12d is basically the 13th term and T13 is therefore equal to 0, which is what I had to prove in this particular problem. So take a look at the solution and then we will continue with the next question. Let's take a look at the following question. In a flower bed, there are 23 rose plants in the first row. So this is the first row which contains 23 rose plants. This is the first row. 21 rose plants in the second row. So in the second row, there are 21 rose plants. There are 21 rose plants in the second row. Then there are 19 plants in the third row. So there are 19 plants. There are 19 rose plants in the third row. And so on. And in the last row, there is only one rose plant. So there is one rose plant in the last row. So let this last row be the nth row, right? And there is only one rose plant in this particular row. We have to find how many rows are there. So let's try mapping this particular question to an arithmetic progression question. So if I write the number of rose plants, I can say that in the first row there are 23 roses or rose plants. Second row there are 21 rose plants. In the third row there are 19 rose plants, and so on till in the last row there is only one rose plant, right? So this is basically my first term, that is T1. Then T2 is 21. T3 is 19, and 1 happens to be Tn. Now I know that Tn is given by a plus n minus 1 times d. What am I supposed to find here? I am supposed to find how many rows are there. That means I am basically trying to find the value of n over here. So I can say that the nth term is 1 is equal to a is 23 over here, plus n minus 1 times, now d is the difference between two consecutive terms. So d can be written as 21 minus 23, which is probably minus 2. So d is therefore minus 2. And hence 1 is equal to 23 minus 2n plus 2. And therefore 1 is equal to 25 minus 2n. And solving this equation, I get n is equal to 12. Therefore, I can say that there are therefore 12 rows of rose plants, right? This is how I can solve this particular question. So again over here, the key was to convert the given word problem into an arithmetic progression problem. And then we could use the different formulae that we know for arithmetic progressions to find what was required. So again, I will pause for a minute. Moving on to the next question. Let's take a look at the following question. Subba Rao started work in 1995 at an annual salary of rupees 5,000. So in the year 1995, his salary was rupees 5,000 and he received a 200 rupees salary raise each year. So in the year 1996, his salary became rupees 5,200. Then in 1997, his salary would become rupees 5,400 and so on. This would continue. In what year did his salary reach rupees 7,000, right? This is the question. So in which year did his salary become rupees 7,000 per annum? So again, if you notice, the salary is an AP, right? So the salary is an AP as well as the years are also AP. So the salary is, so salary of Subbarao forms an AP with, I can say that the first term is equal to rupees 5,000. The first term is 5,000. The common difference D is rupees 200 and the nth term is rupees 7,000, right? And therefore I'm trying to find n over here, right? I'm trying to find n here. So I can say that Tn is equal to A plus n minus 1 times D. Now Tn is 7,000. So 7,000 equals A is the first term, that's 5,000, plus n minus 1 times 200. And solving this, I get 7,000 minus 5,000 is 2,000. So 2,000 is equal to 200 into n minus 1. And therefore 2,000 by 200 is therefore equal to n minus 1, which means n is equal to 11, right? So his salary will reach 7,000 rupees in the 11th year, right? So when I say that it is the 11th year, what basically it means is I actually have to find the year, right? Now 1995 happens to be my first year. That means now let's see which year it is. So again, let us write the years. The years are 1995, 1996 and so on. And therefore I have to find T11 in this particular sequence of numbers, right? The years also form an AP if you notice. So T11 will be, the first term is 1995 plus 11 minus 1 times D. The common difference is 1. And therefore this is going to be 1995 plus 10, that is in 2005. So his salary would therefore be rupees 7,000 in the year 2005. In the year 2005, right? So this is how I solved this particular question. Again, I first took the salary. The salary of Subbarao was actually forming an arithmetic progression. So I found in which year or which term was 7,000 in this particular arithmetic progression. I found that it was the 11th term, and then the years again formed an AP. So 1995 being the first year, and I found the 11th term in this particular AP of years, and I got the answer as 2005. That means his salary would be rupees 7,000 in the year 2005. Again, pausing for a minute. We end our session over here today. So we will try out some more different concepts and problems of arithmetic progressions in the next session.